This is the AB 5-3 review. Calculators are allowed, and it's number 9. So on number 9, all three of these, I'm given a function defined as an accumulation of another function, and then I'm asking for when f has a local minimum on a closed interval. So the first thing we're going to do is we are going to determine the fact, or remember the fact, that we get local mins at either endpoints or at critical points. So we need mins occur at endpoints or critical points, and in particular we're looking for when f prime of x equals 0, and since we want minima, we're going to be changing from negative to positive. So when we look at this, we need to know what f prime is. Well, f prime of x will be the derivative of this function, which is just cosine of x squared. So we're going to be looking at the graph of this on the interval from 0 to 3. So we're going to go to our calculators, into the y editor, and we will put in the cosine of x squared. Oops, escape, sorry, I don't know where I went. Cosine of x squared. And then we're going to change the window so that we're looking from 0 to 3. And then we know cosine, the biggest it gets is -1, or +1, and the smallest it gets is -1, so we'll just leave our window as -1 to 1, and then we'll graph it. Now remember, we're looking for where it crosses the x-axis and where it changes from negative to positive. So looking at this picture, we can see that we have a maximum here, then we've got a minimum, then we have another maximum. So the only location for a minimum that is interior will be this one right here. So I'm going to go find that 0. I'm currently on the left of it, then I'll move to the right, and I can see that I have one minimum at x equals 2.171. Now we also need to consider whether or not we have a minimum on the endpoints. So if we look at what this is telling us, this says that my function has a positive slope because I'm above the x-axis. That means from my endpoint I'm going to start by rising. So that means this endpoint is going to be a minimum at 0. Now if we check the other end, I have a negative slope until 3, so that means the original function will be falling until it hits the endpoint. So that means 3 is also going to be the location of a minimum. Now that we've considered all of them, we are done. So let's look at part B, which works the same way. Again, we have a closed interval, and we're interested in when we've got a local maximum this time. So we want g prime, which is the same as the derivative of this, or a sign with that x plugged in. And we're looking for changes from positive to negative on this one. So again, we will go to our calculator, and instead of having a cosine of x squared, we're going to have a sine of x squared. Our window in this case is going to be from -3 to 1. And sines and cosines both have that same range, so we're not going to change our y values. If I graph this now, we're looking for when it crosses from above to below. So we can see that there's only one time when that occurs, and it's right here. So here we change from a positive g prime to a negative g prime. So that means we're going to look for that 0. We need to get all the way to the left, so I'm going to try -2.5, see if that takes me. Not quite. Yeah, I know, sorry. There's a lower bound, then we've got to move to the right. So there's an upper. We end up with a max at x equals -2.507, and now we got to check the endpoints. So again, on the left endpoint, I have a positive slope because the graph of g prime is above the x-axis. That means from the left, I'm going to rise. Because I'm rising, that means this endpoint over here is going to be a minimum. It's not a maximum. If we look on this side, however, the slope is positive. It's above the x-axis. That means until I get to that right endpoint, I'm going to be rising. So on the right side at 1, we are actually going to have a maximum. If we look at the final one, part C, we have the same thing, except now we've got a different interval and a different function. Oh, and I'm going to have to do the chain rule. So we need h prime, which means I'll plug in that x squared. So x squared squared will give me an x to the 4th. And then because this x squared was a function of x, I need to multiply by the derivative of it and get a 2x. So I want a local minimum. So that means I need the graph of this to give me, to cross from below the x-axis to above. So I'm going to change that out and make it a tangent of x to the 4th times a 2x. And then I'm going to go to my window. I want to go from negative pi over 4 to positive pi over 4. And tangent actually gets pretty big and pretty small, but because I'm only interested in when it crosses the x-axis, I can still keep it from negative 1 to 1. So if I graph now, I will be looking for minima. That means I need this to cross from below the x-axis to above the x-axis. And we can see it's happening somewhere in here. So I'm going to do a 0, and I know that it is probably before, or that would be below because I'm underneath, and I need to be to the right. We definitely know that'll be to the right. Hit enter and it occurs at 0. So I have a minimum at x equals 0. Now let's test the endpoints. I have a negative slope after my left endpoint, which means I'm going to be falling, so that will be a max. And on this one I have a positive slope because the graph of h prime is above the x-axis, so that means I'm rising until I get to my next endpoint. So that's also going to be a max. So my only minimum occurs at x equals 0.